Hi guys, so what we're going to do is complete a graphic organizer on the properties of logarithms. And there's a couple different things we're going to talk about, and those are going to be the basic logarithms, the product rule, the quotient rule, the power rule, the change of base formula. Okay, so let's start with basic logarithms. And so what we need to remember for those is that this is where you're going to be converting between log form and exponential form. So remember, exponential form is the base raised to an exponent gives me an answer. So b to the x equals a. In log form, I then have the log of a base of the answer equals x. Okay, so here log base b of a gives me x, and in exponential form, b to the x equals a. So we have rules here, which we didn't really talk about 100%. So what I want to do is go through the examples first with you, and then we'll go back and fill in the rule. Okay, but this first rule deals with a log base b of b. So here, log base 14 of 14, let's simplify that. Well, how do I do that? What we're really doing by simplify is we mean evaluate. Okay, so how do I do this? I put an x here because that's what I'm looking for. I'm looking for an answer. I'm looking for my x. Okay, in order to do that, let's write it in exponential form. So the base, so 14 to x, okay, so the x goes up here, equals the answer, what's in the a spot, okay, equals 14. And now all we need to do is figure out what goes up here. What's that exponent? 14 to the what gives me 14? Well, 14 to the 1, so I have 14 to the 1 gives me 14. So here, remember, I'll have 14 to the x equals 14 to the 1. And now I have the same base, so x equals 1. So in this case, log base 14 of 14 equals 1. So log base b of b equals 1. When the base and the number here are the same, you're going to get 1 as your answer. All right, so let's look at this next one, which is we're going to find the rule for log base b of 1. In this case, log base 3 of 1. Well, let's just set that equal to x so I know how to convert to exponential form here. And then I'm going to just rewrite it. So my base is 3 to the x equals a, and my a is 1. So now that I've done that, I need to figure out how do I get a 1 from a 3? So I'm going to say 3 to the x equals 3 to the 0 power. So now, remember, anything to the 0 power is 1, which means x equals 0. So log base 3 of 1 equals 0. So anytime I'm taking a log of any base of 1, I'm going to get 0 as my answer. Okay? All right, let's look at the product rule here. So my product rule, don't forget, means I'm going to be expanding this into 2 logs, and I'm going to add them together. So when we have the product rule, I'm not multiplying. Product is multiplying. Okay, I have to make 2 logs and add them. So I need 2 logs of the same base. So log base b of m plus log base b of n. And now let's condense and expand. And condensing, I have 2 logs here of the same base, log base 5 of 6 plus log base 5 of 7. So I have 2 logs of the same base. So what I'm going to do is I'm going to make it 1 log base 5 of 6 times 7. and that just becomes log base 5 of 42. I'm not going to solve this here because it's not asking me to. Okay, I'm not solving an exponential equation. I'm just condensing this. It doesn't say evaluate. It doesn't say any of that. It just says condense. So now here we need to expand. Well, when I'm expanding, that means I'm adding 2 logs of the same base. So I need to add 2 logs of the same base. But before I do that, I know I'm going to have log base 2 of something times log base 2. I could write this a little lower. So let me just write this a little lower down here. Okay, so log base 2 of something plus log base 2 of a number. And what number can go in here? Well, I need to figure out 2 numbers that multiply to 63, and I can come up with any 2 numbers. I'm going to say, let's do 21 times 3. So log base 2 of 21 times log base 2 of 3. All right, so my quotient rule, I'm just going to move this up just a little bit. All right, so my quotient rule here, now we're dividing, and when I'm looking at logs and I'm dividing inside my of part here, I'm going to subtract. All right, so the quotient goes with subtraction, so we're going to log base b of m divided by n expands to log base b of m minus log base b of n. All right, so here, let's condense log base 4 of 84 minus log base 4 of 12. Well, I have 2 logs of the same base, and I'm subtracting, so I have log base b of log base 4 of, and now I'm just dividing 84 divided by 12, and it's just first over the second one. And now we can't leave this. We need to do 84 divided by 12, so we're going to simplify that. In this case, it can be divided, so I have log base 4 of 7. All right, so now let's expand. And since I'm expanding and I'm using the quotient rule, that means I'm going to be subtracting 2 logs of the same base. And in this case, my base is what? 10, because there isn't anything written here. Remember, there's that little invisible 10. All right, and so what do I need to do? Well, I'm dividing here. Okay, so since I'm dividing here, I just erased that so I have some more room. Okay, since I'm dividing, I need the log of 2 numbers that are going to give me 9. So let's come up with 2 numbers that when I divide them, I get 9. Well, okay, how about 36 divided by 4? Is 36 divided by 4 9? Yes, so the log of 34 minus the log of 36, I should say. The log of 36 minus the log of 4. All right, so now let's talk about the power rule here. And my power rule means I'm going to have an exponent in my log form. But if I don't want that exponent, remember the power rule? We just kind of go with multiplying. Even in exponential form, we multiply things. So here, my power rule says, oh, take the exponent and let's swing it to the front. So this becomes that n moves to the front, and it becomes n times log base b of m. So that n just swung itself out there. Okay, so that means if I want to condense it, the n goes from the front to the top. All right, so here I want to condense, so I have to take what's being multiplied over here, and I'm just going to swing it this way. It becomes the exponent of the 8, so log base 3 of 8 squared. Now, because we're condensing when we're seeing the power rule, we can leave it like this, but you should probably make it log base 3 of 64. Because if you were going to evaluate, and we're not going to do that here, but if you were going to evaluate, we'd want it written like this, okay? Now expand means we take the exponent. Well, what's my exponent? And we multiply it. So we have log base 2 of 6 to the x minus 1. So my exponent here is x minus 1. That whole thing is in the exponent. So I'm going to take this whole thing and I'm going to move it right in front. And I'm going to leave it in the parentheses. So x minus 1 times the log base 2 of 6. And we're done. And we leave this in parentheses because otherwise we would have an order of operations issue there. Okay, so now the change of base formula, and this is the one where like you almost don't really need to think at all, you just need to use your calculator. So log base b of a, we use this change of base formula to evaluate when that base chart that we have doesn't work. So here, log base b of a, we just turn that into, let me pick a color I haven't done yet. I really like green. Okay, so log base b of a turns into log of a over, or divided by, the log of b. And how do we remember that the a goes on top and the b goes on the bottom? Well, a comes before b, so a on top, b on the bottom, or b stands for base, and where's the base? On the bottom. So now let's evaluate this using a common base, because here, if I wanted to evaluate using exponential functions, or exponential equations, I would put my x there and I would say, okay, 7 to the x equals 32. And then you'd go down your base chart and you'd say, well, there's nothing in the 7 column that gives me 32, so this isn't going to work. We can't do this, okay? So what we're going to look at here is we're just going to rewrite it as log of 32 divided by the log of 7. And you don't know this, I don't know this. We're just going to, let's swing this over so now we can see the whole thing. Okay, so here I'm just going to go to my calculator, and don't forget Desmo Scientific Calculator. I go over to the function button and I hit log of 32, using my keyboard, divided by is the slash, see how it brings it over, the log of 7, and I always like to make sure I close those parentheses, and I'm hitting enter, and I get 1.781, and go to 3 decimal places. All right. And then the other thing to remember, which we already talked about here, let me make this bigger again, which we already talked about up here, was that, remember, base 10 logs are common logs and they're written without a base. And we saw that when we were dealing with our quotient rule. So if you have a log that doesn't have a base, then you know you have base 10 and it's written just like that. Okay, use this as a guide for you because it's got everything you need on it to help you with these problems.